What's up, everyone? Today we'll be looking at this question: what is minimum absolute difference? I should have loaded it earlier. So 1200 minimum absolute difference. Um, yeah, so let's start the timer and let's see if we can solve the question. Okay, so given an array of distinct integer R, find all pairs of elements with the minimum absolute difference of any two elements. Return a list of pairs in ascending order with respect to pairs. Each pair AB follows AB are from array A is less than B, B minus A equals to the minimum absolute difference of any two elements in array. Okay, I did not get this question. The minimum absolute difference is 1. List all pairs with difference equal to 1 in ascending order. Given an array of distinct integer R, find all pairs of element with the minimum absolute difference of any two elements. Find all pairs of elements with the minimum absolute difference of return a list of pairs in ascending order with respect to pair. Each pair AB follow A and B are from array. A is less than B. B minus A equals to the minimum absolute difference of any two element in array. So I guess minimum absolute difference 4 minus 3 B minus A is less than B, AB are from array, so 1 2 2 3 and 3 4. Okay, so I guess I need to find a absolute difference between find all pairs of elements with the minimum absolute difference of any two elements. So I guess first of all we need to find a minimum absolute difference between the pairs. Like if I do O of n square for 10 raised to 5, that would be too much, but yeah, like I guess I need to what I need to do is I need to find a minimum difference, and then I need to find all those pairs which satisfies that minimum difference, right? Is that right? Am I getting that question right? No way of telling, but if you see this 1 and 2, they both form a pair of that kind. 2 and 3 also form a pair of that kind, and 3 and 4 also form a pair of that kind, which has a minimum absolute difference of 1. So in this case, let's see, 1 and 3 is 2, the minimum difference is 2. So nothing here is satisfying that, so 1 and 3 is the only one. So 3 and 8 is so what companies have asked this? PayPal, Bloomberg, Amazon. Okay, not a lot, but yeah. So 3 8 3 8 minus 10. So I guess to find the absolute minimum absolute difference, I would say I'm thinking that either we have to calculate for the first two elements, like after sorting the array, we'll have to take the first two elements and then find the absolute difference between them. That would be minimum. or or else we can find the difference between last two elements, but as these are uh, the absolute difference can be anywhere in the array itself. I guess we need to search for the absolute difference of. So my time complexity for this algorithm would be n log n for sorting them, then n square for mm, for finding the minimum absolute difference. So again n square for finding the pairs which satisfy that condition. Is that right? Yeah. So that's what I'm thinking. Can we code it out? Yes, we can try to code it out, and let's see if that works. So I did not ask the question if this array, what size of the array will be always 2. Okay, gotcha. So let's see. Let's do one thing. Let first sort arr dot sort a comma b a minus b, so that will sort the array. Then for let I is equal to 0, I is less than arr dot length I plus plus, for let j is equal to I plus 1 and j is less than arr dot length j plus plus. What I need to do is I need to find the minimum difference, right? Let min difference is equal to, let's call it number dot max safe integer, just for the comparison sake. And at any time if we math dot min, if math dot abs arr of I minus arr of j, the with max sorry, min def. So if you just want to let current diff to make the code cleaner, what I'll do is this and current diff. Okay, so what we also need to do is we'll do this, and finally after all of this we'll find our minimum difference, and then let res is equal to an array to which we'll be pushing our um, the difference, and then finally what we'll do is return that res. So let's copy this block of code. I guess this is going to take a lot of time, and it might also um, exceed our time. So then minimum diff equals to sorry, I need to do this again. So let's take this here and do current diff, and if this at all is equal, then minimum diff is equal to, then what we need to do is dot push air of I first, air of j next. So my goal, so that's it, I guess. And my goal is to just check if our test cases just executes. Yeah, so everything gets passed. So basically our logic is right for solving this question, but it's not highly efficient for larger test cases, because yeah, it's going to exceed time limit exceeded. Yeah, I thought so. And this is not very efficient. So how would you um, make it more efficient or reduce the time complexity? Minimum absolute difference. Okay. What is the hint that we have here? Oh, not this hint. Why is this going here? Okay, yeah, hint. Find the minimum absolute difference between two elements in the array. I did find that. The minimum absolute difference must be the difference between two consecutive elements in the sorted array. Thanks for letting me know. What if they are not consecutive? What's so do we have here any consecutive number? No. So sorted array, I know I have already sorted it, but how can I figure out? So okay, so I know the minimum difference now between. So my idea is now what I have is the minimum difference, right? Minimum difference. So if I have this 1 3 6 10 15, okay, let's take this. Let's go to the road. This, I hope this is not reset, or if I do this and delete this, okay, I guess I need to refresh this. Okay, now if I delete this and write, okay, sorry, my bad, 1 2 3 4, right? So the minimum difference here is minimum diff is 1 after traversing. So my intuition is to start from index 1 and then check if the adding taking the previous value and adding the difference lead like if it is equal to the current one. If it is, then we can add so 1 2 will add, then we'll go to 3, we'll add that, we'll take this and add, so 2 3 will take, and similarly 4 3. So that will reduce our time complexity to basically n. So where are we? So we don't have to do this calculation again. So yeah, so for let I equals to 1, because we'll always have two elements, and air dot length I plus plus, what we'll do is I will simply check if air of I minus 1 plus min diff equals to air of I. If yes, then I would like to add that pair to my answer, which is air of I minus 1 comma air of I. So if I do that, it should be quicker. Let's see if our, yeah, this is getting passed. I hope it get, so the only, yeah, it passed, but it was too poor for a solution. So if I sort this, what is the need of me going through check every pair? So all I can do is take one, the same thing, and min diff is equal to number dot sorry, let's calculate first. Let current diff is equal to math dot abs air of I minus 1 minus air of I. So let's find out what is the minimum, current diff or min diff. So that will, I guess, okay, that reduces the complexity. Okay, yeah, it reduces the complexity hell a lot. So our our time complexity for this would be n log n, and yeah, so that's what it is. Okay guys, thank you so much. Thank you so much for watching. I was able to optimize this on the fly, so time complexity of this would be n log n for the sorting, and this is just O of n linear time that we are doing. Space complexity is nothing because we don't consider the result for the space. So that's it. Thanks for